Okay. What's up, folks? So now in this video, we're doing rectified flow, pixel space. Today we're going to do the training video. So far we wrote the training loop. We coded our backbone, our UNet backbone, injecting time step embeddings. And we coded inference. We've tested it. We know that it works, but we don't know what our results look like. We need to do proper science. Proper science is starting with a baseline. And the simplest baseline, right? First, we're doing rectified flow. That's the new thing we're introducing, right? So we need to ensure that our rectified flow module works, right? Which means we need to make sure that this works, rectified flow works, and that we can output, that we can output a velocity head and regress on velocity, right? So in order to make sure that this works, we don't want to introduce too much complexity in our model. We want like the simplest model, the simplest backbone we can possibly use to verify that this is working, right? So like, let's say I'm like, oh, I want to use a diffusion transformer in latent space. Well, if things mess up and our latents don't decode properly, what's wrong? Is it our rectified flow module that's wrong, or is it our diffusion transformer that's wrong, or is it our encoder or decoder that's wrong, right? So I know UNet works because I'm coding UNet based on a backbone that I've already created. The only difference is I'm injecting time step embeddings, but I know how to do sinusoidal and time step embeddings. I've done that, right? So, and then we'll just keep it in pixel space. So the only thing that's varying, right? The variable that's varying, right? The portion that's varying is the rectified flow module, right? So science, it's not nothing crazy, but right? It's simple, but trust me, when you start getting into these things, the urge to just build the most complex thing right away is real. That urge is super real, and you have to be disciplined. You have to be disciplined not only to slow yourself down, but you also do have to use intelligence to know what to control and what to vary. Okay, so I've said enough. Let's do some training on Runpod on a virtual machine. I'm going to use an A100 because I want this to move quickly. So I'm going to select, I've done all this already. I'm going to be better about pointing folks towards the videos where certain code has already been done. So when I say I've done this already, then I can point you to the links in the description. I'm going to do that very, very soon. I've just been focused on pumping out content. But I have a video where I'm using a network volume. So, right, this is a detachable volume, storage volume that I have all of my data and everything on. So I don't have to recreate this every time I spin up a virtual machine. I'm going to use, I'm going to use this A100. I have the only difference between this video and last is I made new config files. Last time I was using config files that I was using for other code. So I just separated it out into this config live pixel space, right? So I have individual config files for this. So yes. So CD into my workspace, right? Here's everything. I'm going to CD into the rectified flow repo. Boom. Here's everything. Git log. Boom. Move model to device. That's the last one. Oh, right. In my coding videos, I forgot to move the model to the device. So I was getting a complaint where all the tensors weren't on the GPU. So don't forget to move your model to the device. Okay. I'll just put something that I don't care for now. Okay, so the first thing, I'm gonna make a README for this and I'm gonna clean this up. It's gonna be nice, but first thing, all right, so just like I did in my videos before, this setup and on creation, if you're creating Runpod, I want you to come into this config folder and grab setup and on creation, and you need to run this entire thing. Just create the file on the pod and run the entire thing. So poetry and everything is installed. And then you need to run yeah, that should be good. But poetry won't be attached to the path. There's this weird thing. I still need to figure this out. So then you need to run config on restart first. And then every time you restart your pod, I like to install Vim and Screen and everything, because you're going to be using Screen. Or if you want tmux, you can use tmux, whatever you prefer. So then you need to set up your variables again, your environment variables, so that you can run poetry commands and Hugging Face. Also, the Hugging Face cache. We're not using it in this project yet, but very soon we're going to be using Hugging Face models, and we need to make sure that all of the cached files get stored on the detachable drive. So now poetry is a command; it's recognizable. So let's look at our config file. So server. I'm on an A100 now, so I'm going to try to increase this to 1024. I think I should be able to. Everything else looks good. I want to save. I don't want to save model. Typically you would, but I already have a run save that I'm going to use for moving forward. But inference peak number. Yeah, we'll do 1. Local visualization false. Right inference samples true. So. All right, let's pixel space server. I think I might be able to do 1024. If not, we'll try 768. So I think that's it. And then you can come to this runtrain.sh. You can grab this, right? I'm just making so you don't have to type out the run command every time. All right. Oh, you'll have to, your first time, I'll add this all to the README, but your first time you'll have to, install the project, right? You have to run poetry install all the dependencies so that you can run this command. You do want to be using poetry, folks, if you're not on that train yet. Nice, so much faster. A100 is so much faster than what was I using before? Ada 2000? So much faster. So I named this server overfit UNet pixel. Well, this is the run. I did change the name, but something weird's going on. But anyways, this is the run. Oh crap. I wanted to set debug to be true. Debug is true. Debug is true and nothing is getting printed. What file is running? Subspace live. First of all, live. That's why live pixel space server train pixel. First of all, that's why I wasn't seeing the name change. So let's delete this. Okay. And then why? Okay. Server train pixel space should have debug to be false then. Yes, okay. That's right. So this should fix it. Oh. I passed in the wrong path to the config file. That's why. So I want to look at the magnitudes of the predicted velocity. It should steadily increase. It'll be a good sign if it is. Yeah, this looks good. This looks good. And then the V star should be close to 1, right? The magnitude should be close to 1. That's why, that's the beauty of doing rectified flow straight line approximations. Right, because we're doing from 0 to 1, so they should all be somewhere in the ballpark range of 1. Anyways, my runs are not optimal. I'm less focused on optimization for now, like for these smaller models, and I'm more focused on just getting content out the door. But I will, probably for this model, I'll have to do some optimization in terms of PyTorch optimization, CUDA optimization. When we look at our samples that the model generates, we're just looking for the general shape of the face, which I think we'll get. If we get that, we'll say this is a success. We can say rectified flow is working, right? Mission success. And then we can move on to changing the data set to something a bit more complex where the model has to learn a bit more features. So Flickr 30K. Expected all tensors to be on the same device. Line 34, UNet pixel space live. Line 94. Oh, wait, well. Oh. line 140. Is there a device call? Expand. T-valves. This is on the device. T-valves, X. DTs is from T-valves. T. Device. Ah. Ay. So device should be right up here. All right, there you go. Git, add, git commit. Remove device param default from function. Okay. Also, yeah, batch size 4. Okay. Huh? Okay. It should work. And then we'll remove do sample true, and then we'll do a run. It should work. Okay. Yeah, I see faces already. It's gonna be, we're gonna have a mission success. I could already call this mission success, but I want to show false. Batch size 1024. All right. We're gonna get images that look like this. I'll keep this run, why not? All right, let's see. What do we got? What do we got? What do we got? Should I refresh? There you go. Yep, we got faces. There you go. Success. Mission success. Okay. That's good enough to prove that our rectified flow works. So next video, I'm gonna do actually, I'm not sure exactly what I want to do yet. I think I might just bump up to text conditioning instead of doing a Flickr K run, because I think you all that are following along are good enough to do that on your own. Maybe I'll just add the content to the README. All right, folks, thanks for watching. Later.